Let us understand the concept of analysis of variance two-way. So I'm going to use two-way analysis of variance here, and there's going to be a two-way analysis of variance, and I'm going to straight away variance ANOVA two-way. You can think it like this. So I'm going to straight away use a particular question, and I'm going to understand how I'm going to use a two-way analysis of variance. So let's see. There are three products. These products are called A, B, C, and there are three marketing strategies: M1, M2, and M3. And fundamentally, these are their sales figures. On a You can multiply it with thousand or hundreds, whatever you want. And these are their sales figures: 594. And okay, I just need to make a data correction. Just a minute. Uh, right, to make a data correction here. Yes. Okay, so it is 788. I've got something called 976, and then I have something called 5, 9, and 4. So fundamentally, there are three marketing strategies, three different products, and these are their sales in number of units. You can multiply it by 1000 or 100 if the numbers are big enough. And and what I'm trying to observe is this the different marketing strategies which actually are impacting the deviation in the sales, different sales of three different products. That means if product A is treated with marketing strategy 1, 7 units are sold. Product B is treated with marketing strategy 1 and the 8 units are sold, and product C is treated with marketing strategy 1 and 8 products are sold. Or this is just because the products are different. So these could be three different types of, I would say, pilot pens a company is actually launching, and all three are having different look and feel, or and they probably are of same cost, and but they are selling differently. So if the products are different, that's why their sales are different, or because of marketing strategy, there are different variation in that. So this is called a two analysis variance analysis of variance. I'm trying to understand whether the products are different from each other. That's why the sales are different, or the marketing strategies are different. That's why the sales are different. Or probably I'm trying to understand that the both the things like marketing strategy collectively and products are actually creating an impact. So I can create a null hypothesis here such way that no significant impact of product difference. So no significant impact of product difference. That means the difference of the products is not creating an impact on the sales. And alternatively, I can think about no significant impact of different of marketing strategies. So I'm writing it MS. So what is going to happen? Let us suppose null gets rejected, alternate gets accepted, then marketing strategies actually create an impact on sales. Other way around, null doesn't get rejected, alternate gets rejected. And in that particular case, the products are different. That's how the sales are different. Its marketing strategy has no impact at all. Both are rejected. That means neither. That means products are different as well as marketing strategies are different. So collectively, they are creating an impact on sales. Both are accepted. Then in that case, neither marketing strategies nor the differentiation of the products creates an impact on the sales. So that's how the interpretation goes out. But let's see at alpha is equal to 0.05. I'm going to test this on the hypothesis. And right, and I am going to calculate once again an F critical score at 0.05. And I'll be talking about degrees of freedom again in a little later stage. But right now, Let's see, like we did in uh, our analysis of variance table 1, then what kind of table actually we are going to fill up here. So I'm going to get a source of variation. So I'm writing it source of variation here. And in this source of variation, I'm going to have something called sum of squares amongst the columns. Sum of the squares amongst the columns, SSC. That is what I'm going to observe. That means in first column, what is it, second column and third column. So, okay, I'll write it this way. This is SSC. Then other is sum of squares amongst the rows. So I'm going to understand something in rows in this direction. That means in this direction. And then third entry I'm going to calculate is uh, I'm going to calculate. Okay, let me rewrite it once again. Let me just go through it right, and I'll write it in a better way. So then so by mistake I have used it. Let me rewrite the table once again. Okay, and sources of variation. I'm going to make it a little bit this time. So first is sources of variation amongst the columns, and it is sum of squares. So I'm going to calculate something called SSC here. Then amongst the rows, I'm going to calculate something called SSR here. Between the rows, between the columns, so I'll write it between the columns, between the rows. And then I'm going to calculate something called residual error. Residual is deviation of a particular value from the expected value. And then I'm going to calculate the total here. It is going to be SSE, and then I'm going to calculate SST, and then I'm going to get degrees of freedom, which is the easiest calculation. Then I'm going to calculate some MS values, and these MS values are again MSC. Then that is exactly amongst the columns. I'm going to calculate something called MSR. Then I'm going to calculate something called mean sum of squares, sum of square errors. And here I'll be calculating two f values. The first f value would be simply MSC divided by MSE. That is my first f value. And the second f value would be MSR divided by MSE. So this is the table which I'm going to calculate. And these two f values will be tested with respect to my f critical scores, which I'll be again discussing a little later. So if I see the degrees of freedom, first of all, so if I see there are three columns, 1, 2, 3 columns, and my degrees of freedom definitely are going to be 2 here. If I see my rows, there are 3 rows, again my degrees of freedom are going to be 2. My total, I have 9 observations, so total sample size is 9, n minus 1, 9 minus 1, and that is exactly 8. And that leaves me with an SSE degrees of freedom 6. So it is, I think, conveniently easy to understand the entire thing, right? Okay, so this is 4. I'm sorry, let me clean it up. So this is going to be 4 because 2 plus 2 is 4 and 8 is here, and as you see, this is the total. So I'm left with 4, right? So other way around, you can think it is about column minus 1 multiplied with row minus 1. These degrees of freedom are column minus 1. These degrees of freedoms are rows minus 1. So you see there are 3 columns minus 1, 2, 3 rows minus 1 is 2, and so on. So this is the easiest calculation. Let's see, how do I calculate SSC? So I'm going to put the formulas here for SSC. Formula is sum of Tj square divided by Nj minus gt square divided by n. So for the people who have seen the first video of one way ANOVA, For them, this is no different at all. It is sum of columns square divided by ng. And SSR is Ti square divided by Ni. That means rows, I'm going to go with the row totals, Gt square divided by N. Then I've got a formula for SST. That formula is given by sum Xij square minus Gt square by N. So if you see the game plan here, I'm going to get a value of SST, and so I'm going to get a value of SST. I'm going to get a value of SSC, sorry, SSC, SSR, and SST, and I will add SSC, SSR, subtract it from SST, and I'm going to get the value of SSE, and that's how I'm going to progress with it. Let's calculate SSC first. So I see, let's sum the total columns here. So this sum is 21. The second column sum is 24, and this is 18. And we sum the rows. Okay, I'll sum it later. So Tj square by Nj. So the first one is going to be 21 square divided by 3 plus 24 square divided by 3 plus 18 square divided by 3 minus gt square by n. Gt means sum of all. So it is going to be 7 plus 8 plus 8 plus 9 plus 7 plus 6 plus 5 plus 9 plus 4. And that is supposed to be divided by, this square is supposed to be divided by 9. So once I calculate this SSC, you use a calculator and solve it out, then you're going to get Tj square by n as 447, and the gt square by n, you're going to get something called 441, and the subtraction is going to give you 6. Now I'll use a different color to calculate SSR and Ti square by n, and I'm going to sum the rows here. So this first sum is 23, 9 plus 7 plus 6, that gives me, okay, 22, and then the third sum is 18. So how I calculate it is going to be 23 square divided by 3 plus 22 square divided by 3. There are 3 entries, right? 1, 2, 3, 1, 2, 3, 3, 3. So sample size in that particular uh, row is 3. So it is 18 square divided by 3 minus gt square by n, that I clearly know it is 44, 41. And when I calculate this SSR, so that is going to give me something, and let me just check it out. So if I start calculating it, it is going to be 23 square divided by 3, 445.67 minus 441, and that gives me 4.67. Okay, let's go for SST. Let me change the color once again. Okay, I'll pick a lighter one. SST I'm going to calculate. So this is pretty much known. If you see from the previous problem, it is going to be 7 square plus 8 square, squaring each of the observation and summing it. That is exactly what I'm doing here. Plus 5 square plus 9 square plus 4 square, and that is exactly xij, and I'm going to subtract it by gt square by n. I already know it's 441, and once I calculate it, it's going to be 465 minus 447. That gives me a value of 24. So I have my SSC, which is equal to 6. Here I have my SSR, which is equal to 4.67 here, and I have my SST, which is equal to 24 here. So 24 minus 6. So I'm going to sum SSC plus SSR. I'm going to sum these two, subtract it from SST, and I get this value. So I'll write it. Let me write it more clearly. So 6 plus 4.67, and that exactly gives you SSE value. So what is going to be the SSE value if you try to find it out? Okay, let me calculate it very quickly using my calculator. That what is going to be the SSE value. So it is 13.34. So I have my SSE value. Now I think it is pretty easy now. I can calculate MSC. MSC would be SSC divided by degrees of freedom, and SSC is 6 divided by 2 degrees of freedom, and it is simply 3. You can see that. So this value is 3, and then I calculate my MSR value. MSR, if you see, that is going to be SSR divided by the corresponding degrees of freedom, and that is exactly 4.67 divided by 2, and that is 2.34. It is going to be 2.34. Now to calculate my MSE value. So if I see my MSE value, that is going to be SSE divided by corresponding degrees of freedom. That is simply 13.34 divided by 4, and that gives me 3.34. Let's calculate MSC now. So I'm going to use once again a different color here. Okay, let me click red this time. Okay, then we calculate F ratio, the first one, which is MSC divided by MSE. So it is going to be MSC, that is 3 divided by MSE, which I have. Okay, I have to pick one more time. Right. My MSC is 3.34. So this is exactly 3 divided by 3.34. And my first F value actually comes out to be 0.7. You see my F2 value, which is exactly going to be MSR divided by 3.34, which is exactly 2.34 divided by 3.34, and that gives me a value of 0.9. Okay, I think this calculation is a little messed up. So this is okay. So this is 0.9. I'm sorry, and this is 0.7. So let me correct it. Let me correct these figures here. Okay, so it is 0.9, 0.7. Let me use my calculator and be sure about it, because I think there is a little glitch in this entire calculation. Let me quickly cross check it for once. So my first is 3 divided by 3.34, and yes, it is 0.9, and the second is 2.34 divided by 3.34. Yes, it is 0.7. I'm absolutely correct now. So here I've got 0.9, right? And here I've got 0.7. So listen, which hypothesis? Let me see the F value. So I'm going to see it as 2 degrees of freedom of row, 2 degrees of freedom of column. And what I get using the F table. You can cross check it once again. I don't want to get into it. You can see my first video how to check the F table. So twice you have to see the F critical. So you will get two same F criticals because degrees of freedom in both the cases is same 2 and 2. So you are going to get this particular F critical value as uh, two F criticals you will get. It will be these two values are there for F score 0.9 and 0.7, and I'm going to get a F critical value of 6.94 here. And what I'm going to do is quickly I'm going to drop a curve. I don't know where. I will just create a space here. So I have 6.94, something of this sort. This is 0. I calculate first of all. So this is actually columns, and which hypothesis is for columns? So if you see no significant of product, so this hypothesis is for columns, isn't it? Product difference, ABC. So I'll compare it. It is falling well below. So I do not reject H0. So first is do not reject H0. Now I'm going to take another color and see what exactly happens with 0.7. So this is rows. So these are the rows, right? So marketing strategies. So I see here is 0.7, which is again well below. So I also see do not reject H1. So this gives me a very clear hint. Neither H0 nor H1 is rejected. That means neither the product differentiation nor the marketing strategies are creating this deviation of sales. It is purely a matter of chance. So that's a two-way ANOVA for you. Thank you very much. And this completes the hypothesis testing. Thank you.